Algebra 1 students, in this video we're going to be working on how to factor using the greatest common factor. In order to factor using the greatest common factor, we need to know what the greatest common factor is. So I have a quick definition written down for you. I established this to be the highest common factor that all terms have. Okay, what the heck does that mean? When we're finding the greatest common factor, okay, we want to look for the two things. First of all, we want to look for the largest number that we can divide all terms by. All right, so let's do that for the first example. In my first example, I have 5x cubed and 25x squared. All right, so part of my GCF is going to be finding the greatest number that I can divide all the numbers by. So 5 and 25, the largest number I can divide 5 and 25 by is 5. So 5 will be part of my greatest common factor. All right, the second part of that is deciding the most amount of variables all terms have in common. All right, so if I look at this first example, I have 5x cubed and 25x squared. So this first term has 1, 2, 3 x's. This second term has 2 x's. If you were to describe to me how many x's do both terms have at least, this term has 2, this term has at least 2. So therefore, I can take 2 x's out of both terms. They both have at least 2 in common. If you only said 1, right? So if you said, oh, they both have an x in common, here would be the issue, okay? If I took one from this term and one from this term, okay, so let's say that those are missing now, right? Do those two terms, the black and the red terms, still have something in common? Yes, they both still have an x. So you need to make sure that you're taking the most amount of common variables as possible. All right, so when I say taking, what the heck do I mean by that? Let's do the actual factoring part of this problem. Factoring is just undoing the multiplication that was there. So basically, I'm going to rewrite the 5x cubed plus 25x squared as a multiplication problem where the number out in front is going to be my greatest common factor. So this is going to be 5x squared multiplied by something. We have to fill in these blanks. And it gives me 5x cubed plus 25x squared. So since my original problem was 1, 2 terms, in the parentheses, I will have 1, 2 terms. Okay? The first term needs to be filled with the number that I would multiply 5x squared by to get 5x cubed. So 5 times what will give me 5? That answer is 1. X squared times what will give me x cubed? That answer is x. So the first term that in my parentheses is going to be 1x. All right, let's try that again. We're going to do the second term. So I need to fill in the second term with something that when I multiply by 25x squared, I will get 25x squared. So 5 times what will give me 25? That answer is 5. X squared times what will give me x squared? Well, I don't need to multiply by anything because I already have x squared. So I don't need any variables for that second number. We can verify to see if we did factoring by greatest common factor correct. There's 2 things we check for. First of all, in the parentheses, do those terms have anything in common? When I look at the yellow term and the blue term, they don't have anything in common that I can divide them by. So that means I must have taken out the greatest common factor. If they had something in common, then there was a greater common factor. And so then I'd have to go back and try the GCF part again. Okay? The next step to checking to see if I actually did factor correctly is to multiply the problem back out and verify that I get the original. 5x squared times 1x is 5x cubed. 5x squared times 5 is 25x squared. Did I get the original problem that I was presented with? I did, so I must have done my GCF correctly. Now the answer that I want, I'm trying to factor, so the answer that I want is actually this 5x squared parentheses 1x plus 5. Okay, let's try that again with a little bit less of the explanation going on, just a little bit quicker. We'll shorten it up. All right, so the first thing we do is we establish what our greatest common factor. I look at the numbers and I ask myself, what can I divide 3, 9, and 12 by? The largest number is 3. Okay, then I'll look at my x's. Here I have 4, then 2, then 1. The most x's that all terms have, this term only has 1 x, so I can't take more than that. So my GCF is going to be 3x. Okay, then the greatest common factor goes out in front of a set of parentheses. Okay, and the parentheses should be as many spaces long as the number of terms you started with. So here I had 1, 2, 3 terms. So in my parentheses, I need to have 1, 2, 3 terms that I'm filling in. Okay, 3x times what will give me 3x to the 4th? 3 times 1 is 3. X times x cubed is x to the 4th. All right, 3x times what will give me negative 9x squared? 3 times negative 3 is negative 9. X times x is x squared. So my middle term is negative 3x. Last but not least, 3x times what will give me the negative 12x term? 3 times negative 4 is negative 12. And then x times, there's nothing there because I already have the x term. So I don't have to write an x in that last term. Let's just verify really quickly that all of my terms do not have a greatest common factor. I cannot divide 1, 3, and 4 by anything in common. And there are no common variables that I can take from all the terms. So I have in fact established the greatest common factor. We can just double check. We'll multiply this out. 3x times 1x cubed is 3x to the 4th. 3x times negative 3x is negative 9x squared. And 3x times negative 4 is negative 12x. Did we get the original problem? Yes, we did. So therefore, our final answer is, I'm going to erase all this so it doesn't look so jumbled, is 3x times 1x cubed minus 3x minus 4. I hope you enjoyed. Good luck factoring.